Hi, I'm Steve Mills, a Solutions Engineer here at Oracle. I've been doing a series of videos on Oracle Communication Service Availability Machine from a technical point of view, really focusing in mostly on the middleware layer here. We've really used this deployment view of the compute assets that come together to make the OCSAM overall product. We've talked about the NEPs compliant hardware, the carrier grade middleware, how we've combined them, tested them, stress test them, so that from your point of view this is black box integration and all you have to think about is your integration points. And so we've talked about the service availability forum standards here and your management integration there, so that your management solution over here can do the right thing. We've had a video on availability management in particular, which is really the 5 to 7 nines that maintains the availability of your applications. We've talked about systems management, which talks about the integration of these management components through a paradigm called a management adapter, just as our use case to sort of explain how that might happen. And today, this video is really about the application services. So you have these applications at the application layer that are embedded distributed processes that have to cooperate and collaborate in order to carry out their mission. And so basic fundamental infrastructure services are generally called for, such as messaging and publish, subscribe, and others. And really, those are the services we're talking about here with the application services. Here we are really going to draw your attention to 3 different services: the messaging service, the checkpoint service, and the publish, subscribe, event service, which are all independent services available to you to use within the context of your embedded distributed system on an as-needed basis. That is, it may well be, and probably so, that either legacy applications or other things about your environment have already provided or identified the management or the messaging mechanism of choice. And so you would continue to use that. To that extent, these are all optional services, and there's no requirement at all within OCSAM that you use them. However, they are at your disposal, and as we'll see, they have some interesting features that make them more conducive to a high availability kind of scenario. So the first service that we're going to talk about is the messaging service. It's a point-to-point, point-to-multipoint messaging service. And we have 2 scenarios that we're going to send to a queue. Now, the notion of a queue is an abstraction that has a life independent of the receiver. So a receiver generally creates a queue. That queue it lives here, and then a sender sends to that queue by name. And so what happens is it arrives at that queue, there's a callback indicating that the message has arrived, and then the receiver then would go fetch the message and do what he was going to do. Now, the significance of the queue having a life independent of the receiver is the fact that if that queue was sent and that process died right now, and the recovery policy was restart, when it would restart, it would open up the exact same queue, and there it would find that message which it failed to receive upon its death. Furthermore, if other messages were sent to that queue, they too would be on that queue, and so he would have all those messages. Another key feature of the messaging services is the concept of a queue group, and there's a lot of details in here you can't see, so let me just tell you what they are. First of all, a queue group goes by a name. In this case, we call it QA. So from a sender's point of view, it always sends to a name. So whether it's sending to a queue or a queue group, it's just a name from the point of view of the semantics of the API that actually send that message, and it doesn't know any difference. What happens is, in a queue group, is these various processes register their queues so that that they become members of the queue group. And in this case, Q1 and Q3 have been registered as members of the queue group. And associated with the queue group, when it was created, is the notion of a distribution policy. And so you have distribution policies like broadcast or round robin, and round robin is the one we're actually using here. And so in that case, when I send to that queue group, it goes to the queue group, and the queue group looks at the distribution policy, and it's round robin, so it sends the first one to Q1, then the second one to Q3, and then the next to Q1, etc., etc. So you can see, for example, with the queue group, it's a simple mechanism by which you could do, for example, a load balancing mechanism. Because from the sender's point of view, it doesn't know how many queue members there are. And so if other processes show up, and they register with the queue group, well, then it just expands the number of targets on the backside that could be the receivers. And so the sender can send and have no idea whether queues are the number of queues that are actually participating are more or less. So that's a great feature. With the checkpoint service, first of all, let's distinguish between the checkpoint service and checkpointing in general. As a generic thing, the general idea with checkpointing is to get state from an active to a standby so that in the advent of a fault or a failure, that standby can take over statefully in a sub-second time frame. There's various ways you can do that. You could use messaging, for example, to send a point-to-point message from the active to standby so it's stateful. You could have an open database or a database where you're pushing state into the database, and if there's a fault, the standby could become active and then access the data through the checkpoint. So there's a variety of means. There's also, in the case of Service Availability Forum, they have created the checkpoint service. And the way this works is there's the notion of a checkpoint, and a checkpoint has any number of replicas. So in this case, we have an active process, a standby process. The active process opens up a checkpoint which causes a replica to be created, co-located on the node. The standby also opens up exactly the same checkpoint, same name, and therefore creates a replica over here. So now when the active, which is really stateful, has state to push down, it does the checkpoint, it goes into the replica, there's synchronization between this and all of the replicas that are a member of the same checkpoint, and there it's available. So now if the standby were to become active, all of that state information is available for reading right now, and thus making it a hot standby. Another use case here is the case where we have a standalone, a local restart, and this particular application has a recovery policy of restart. So that is, if it should die, the middleware has been informed, availability management framework has been informed that the right thing to do is to restart that application. So it checkpoints state because while it's running, it does have state information, and if it were to die, that state would go away. So it needs a place to put it. So it puts it in a replica. Now it dies, and when it comes back up, it opens up exactly the same checkpoint by exactly the same name, and there's that replica waiting for it, and now it can suck up that data and have it at its disposal. Now it's important to understand that a replica can either be co-located on the same node, or you can qualify it so it lives somewhere else. So even if it was a node scoped failure, the state data could be preserved somewhere else within the scope of the cluster. And then finally we have the publish, subscribe event service. There's the basic notion of channels, and so here I've depicted a blue channel and a green channel. These are just labels. You could use the name of your applications, you could name it by functionality, any criteria that works for you. You can have your various channels, and so what you do is you publish with a pattern on a particular channel, and then any subscribers that have also subscribed based on a filter, when the pattern and the filter match, that constitutes a match, and therefore you get the callback. And so in this first case, in the blue channel we sent, and it was received by one guy, and here this publisher sent to on the green channel with a certain pattern, and apparently these subscribers both do a match, and so they've gotten callbacks as well from that of the same message. Now, one of the interesting characteristics of the channel of the event service is you can set a duration timer. So if I publish an event, and the duration timer is, say, a minute, if this guy was alive and had the right filter, he would get it right now. Meanwhile, if this guy was just being started and wasn't really in a state and hadn't registered with the event service, but did, say, in the next 30 seconds, that event would linger in the system long enough so there'd be overlap and he would get the event as well. And that would be, and there's a guarantee that you will never get two instances of the same message, so you're guaranteed that there's independent atomic events. So those are the application services that are at your disposal. So with that, we finished the overview of the technical portion of the OCSAM environment. I hope this was helpful, and we'll look forward to seeing you next time. Bye.